Hello, this is John from TC Math Academy, and in this particular video, we're going to be working on solving an algebra word problem. And this particular word problem is going to require a decent amount of work to solve. So let's get right into the problem. And of course, we want to first start by reading the problem. So let me go and do that for you. It says, find a man's rate of walking if by increasing his rate by 1/2 miles per hour, he can cover 30 miles in 2 hours less time. Okay, so this is the problem, all right? And feel free to use a calculator. Of course, you're not just going to be able to just do this real quick. I would say this will probably take you a good 5 to 10 minutes to solve, right? Probably at least 5, but for most students, maybe like 10 minutes. So if you're up for a challenge, go ahead and pause the video and put your answer into the comment section. I'm going to show you the correct answer in just 1 second, and then I'm going to walk through the solution step by step, and we're going to be covering a good amount of information. So if there's anything you don't understand in terms of the algebra, I'll kind of give you some guidance before we kind of really get into the details to solve this. But if you get lost anywhere along the way, just make note of that and follow my recommendations. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and get to the answer, as we do have a lot to cover here. So find a man's rate of walking. That really is the question. What is his, now if you don't know what the word rate is, I'll just tell you that's basically speed or velocity. Let's find this man's speed of walking. That's his current speed. And what is the answer? Well, let me go ahead and show it to you right now. The final answer to this problem is 2.5 miles per hour. Now, if you got this right, okay, that is super impressive. And I don't do this too much in my videos. I certainly give nice little happy faces and A's and A pluses. But in this particular case, I'm going to give an A plus plus plus, and I'm going to give you like 150% multiple stars. Matter of fact, I'm going to give you a good old-fashioned 1983 Mohawk haircut. Listen, what I'm trying to say is, just like this haircut was way back in the day, this is super impressive. That is awesome if you got this right all on your own. Okay, now at this particular problem, I would say in terms of level of difficulty in algebra word problems, it might be something like maybe like a 7 out of 10. Right, so this is just not a basic word problem. There is a good amount of steps involved, but this particular word problem is a very common type of problem, right? And not this specific problem, but in terms of kind of the topics involved and the methods that we use to solve this problem. But if you didn't get this right, please don't get discouraged. And I'm going to state right up front that I'm going to be using a lot of algebra, obviously, to solve this problem. Okay, and I'm talking about a lot of different algebra skills. Now, if there's anything you don't understand, I'm going to direct you to checking out like my full Algebra 1 course. Okay, because again, there is going to be a lot of different type of things, moving parts to the solution here. So don't, allow yourself to get overwhelmed. Just say, oh, I don't understand this, this, and this, and work on those kind of weak areas. Okay, so with all that being said, let's go ahead and get into the problem. And again, here's the problem. I already read it once. I'll read it again here in a second. But before we start the problem, let's just quickly review some general steps to solve any algebra word problem. Okay, now these are kind of my steps, but in most textbooks or most teachers, you're going to find kind of similar steps. But these are just guidelines to solve algebra word problems. You're never going to get like a one perfect like recipe that if you do this, this, and this, and this, you'll be able to solve every word problem, because it just doesn't work that way. So you're just going to have to kind of use some guidelines. And the first thing you want to do is read the problem. And you might be saying, well, of course, Mr. YouTube Math Man. Well, you don't really kind of, get the meaning of what I mean by step one if you don't tune in and look at this 3x. Okay, you need to read a problem a minimum 3 times. Okay, read the problem once, kind of get a sense of what's going on, read it again, start pulling more information, and then read it at least one last time to really make sure you understand what the question is. Okay, and it doesn't hurt to read the problem even more than that, because here's what a lot of students do. They'll just read the problem one time, they'll be like, oh, okay, I know what to do. They'll start doing a bunch of stuff, and then sometime halfway through the problem, they'll get confused. They'll be like, oh, wait a minute, let me go back to the problem again. And they'll say, oh, wait a minute, I had it wrong. And then they'll have to kind of start again, right? So you don't want to do that. You'll want to take the time to, fully understand all the information. Think about it before you start, okay? All right, so the second thing is you want to come up with some sort of model. In other words, you just want to try to graphically model the data in the problem. This could be all sorts of forms. It could be like a little sketch, a diagram, a table, whatever the case is. And it doesn't have to be just one type of model, but try to model the information in the problem. Now, we are talking about algebra, so you're going to have to express things in terms of a variable, right? So you're looking for some unknown value, right? The question, it is a question. It's asking, to find some unknown value. And when you select a variable, typically that's the value. That variable is going to represent that unknown that you're looking for, right? So we need to select and define some variables, a variable or variables, depending on the type of problem that you have. Now, to solve for that variable, to figure out what that variable is, the actual value of it, well, the only way you're going to do that is you need to build yourself an equation. So you're going to have to relate the information in the problem to construct an equation. And then once you have that equation, you have to have the algebra skills to solve that equation. And of course, we could be talking about all different sorts of equations, quadratic equations, linear equations, systems of equations. You kind of get the picture. And then the last step here is you answer the question. Now, some of you might be saying, well, after we solved the equation, didn't we answer the question? Well, oftentimes, yes, okay, but that's not always the case. So when you solve an equation and you get that solution, you have to ask yourself, does this, fully answer the question? There is a good amount of times where you actually have to take your solution and, do a little bit more to it to actually get the correct answer to the original question. So you always want to think about that. Okay, so these are the kind of general guidelines. And if you want, of course, write this down in your notes, that's perfectly fine as well. But now let's go ahead and get into this problem. I'm going to be covering a lot here, so this video isn't too lengthy. Again, if there's anything that you don't understand, check out like my Algebra 1 course. If you're at the Algebra 2 level or pre-calculus level, you can check those courses out as well. Also, I have additional videos on my YouTube channel that can help you out with this stuff. Okay, so let's go ahead and read the problem again. We want to find the man's rate of walking. Okay, that is the question. We talked about what the word rate is. It's a speed or velocity. So that's what we're looking for. So we want to find the man's rate of walking if by increasing his rate, in other words, he's sped up, right? He's walking at one rate, then he speeds up by 1/2 miles per hour. He can cover this 30 miles in 2 hours less time. Okay, so we have this distance 30 miles, and we have hours going on here. We have rate or miles per hour. Okay, so I'm going to get into this in a second, but let's try to kind of model the scenario. Okay, so here is this man. He's going to walk 30 miles, right? That's what the problem is indicating. And he's at some current rate right here. And he goes, takes him a certain amount of time to cover this 30 miles, all right? But we do know that if he speeds up, his rate is increased by 1/2 mile per hour, that he can cover this 30 miles in 2 hours less time. So whatever time it took him to originally cover it, he can do this, faster by 2 hours. So just take that original time, subtract 2. Okay, so, this is a simple model. And, having a model like this just helps you clarify or pulls the data from the problem so you can see what's going on. Now, a model is just kind of a way to assist you to kind of see what to do next, or to kind of really make sure you have a grasp on all the key components of the problem. But we're going to have to do something additional here to solve this problem. Now, before we go any further, we need to think about a formula. Okay, so we have kind of the relationship of what's going on here, at least visually, but we don't have is a formula. Okay, because what we're dealing with is rate, time, and distance. Rate, time, and distance. So how do these relate to one another? Well, they relate to one another by this formula. Now, there is a lot of formulas in mathematics and in science. I'm going to tell you right now, this formula you want to commit to your long-term memory. This is going to be used over and over and over again. So it's rate times time is equal to distance. And you got to be very mindful of the units of measure when you use this formula. So let's talk about rate. When you see the word rate, you're talking about speed or velocity. Okay, so if you're thinking about how fast a car goes, a car is going 60 miles per hour or 70 miles per hour. So in this particular problem, we're talking about miles per hour. Now, our time is going to have to be related to our rate in terms of miles per hour. Okay, this is miles. This miles per hour is miles per 1 hour. Okay, that is the rate that we're going. So our time needs to be in hours. Okay, so all these units of measure need to be kind of aligned, right? So if we have miles per hour, our time has to be in hours and our distance will be in miles. But what can happen, and it's pretty frequent, that you'll be given a problem where you have to do some units of measure. So in other words, your rate can be in miles per hour, and then your time might be in seconds. Okay, so if that's the case, you're going to have to convert those seconds into hours. But if we were dealing with the rate of meters per second, then our time would be in seconds and our distance would be in meters. So you have to be very mindful of the units of measure that are going on when you're using this formula and other formulas as well. Very, very important. Okay, so this is the formula that you need to know. And if you didn't know this formula and you want to go ahead and just continue to try to solve the problem on your own, I think that's great. But this is the formula that you need to understand and commit to your long-term memory. Okay, so let's go back to our little model here and think about this. So again, our rate, our speed of the man walking is in miles per hour. The time, therefore, will be in hours. And that kind of makes sense too because we're given some information that, he could do it 2 hours less, covering this 30 miles. And then the rate is 1/2 miles per hour. We already talked about that. And then, of course, the distance is in miles. So we're all good to go in terms of units of measure. But now we need a way to kind of organize all this information. So how do we do that? Well, what we're going to do is use a table of values, okay? And constructing a table is a great way to solve algebra word problems. It's actually a very common way. And before we do this, though, we need to select a variable. So you can use any variable. I'm going to use the variable x. So I'm going to let x equal the rate of the man walking at his current rate, okay, his slower rate, right? And that'll be in miles per hour because that is what the question is asking, okay? It's not doesn't represent the rate when he increases his speed. It's his current rate, his original rate. You can think of it as the slower rate or his current rate. So we're going to let x equal his rate. Again, that is going to have the units of measure of miles per hour. Okay, so next we're going to construct a table of value like this. So you can see I have rate, time, and distance, and you want to be thinking rate times time is equal to distance. Okay, so you want to be thinking that. Now, of course, this is not like a formula like this, but this is what you want to be thinking. And let's start kind of plugging in some information here. So here, let me kind of put this here. This is when he's walking at his current or slower rate. This is this row here is when he's speeds up. So if he's going x miles per hour, he's going to cover 30 miles, right? But in what time? Well, we don't know that. I'll get back to time here in a second. But we do know that if he speeds up about 1/2 mile per hour, he's going to cover this 30 miles. Whatever time this is, it's going to be less than 2 hours, right? Okay, so it's going to be this time subtracted by 2 will be that time. Okay, but how can we come up with an expression for time? Okay, it's not quite clear here because we don't have any reference to time in terms of how long it took him to cover 30 miles in either scenario. Well, what we can do is the following. We need to kind of revisit our formula. Rate times time is equal to distance. And let's rewrite this formula in terms of time. Okay, so in other words, this formula is in terms of distance. Okay, rate times time is equal to distance, but I can reshuffle this formula and put it in terms of time. Okay, what I can do is just divide both sides of the formula by rate. And so now I come up with a new formula that time is equal to distance divided by rate. Okay, this formula is equivalent to this formula. It's just written in terms of t and not d. Okay, same formula, just we just solved for a different variable. So our time can be expressed as distance divided by rate. Now, if I kind of think about that for a second, I'm like, oh, okay, our time can be distance divided by rate. Well, I have distance here and I have rate here, so I can use this piece of information to get my time. And whatever this is, this time down here is going to be 2 hours less. Okay, as promised, there is a lot going on here. If you are already kind of like have steam coming out your ear, you're like, you might be thinking, boy, this is just too much. Listen, you can definitely solve algebra word problems. It just might be kind of a lot skills that you're kind of rusty on, right? So, and these problems take time. You're going to have to, really work through and have the patience and discipline just to do these things one step at a time. So stick with me, and let's go ahead and fill out the rest of this table here. All right, so here we know that time, we just kind of talked about that right now. We can define that as distance divided by rate. So let's go ahead and do this here. So if time is distance divided by rate, this time here would be the distance 30 divided by the rate of x. So the time this man took to walk at x miles per hour, 30 miles, the time would be 30 over x. Now we know the problem says that if he speeds up by 1/2 miles per hour, his time is reduced by 2 hours. So instead of taking or writing an expression distance divided by rate, what we're going to do is use this time, 30 over x, and subtract 2 from it, because that is, in fact, the time, the problem, and that information was given to us in the problem. So a lot of students, would say, oh, I'll take 30 divided by this. Just write, think of it in terms of this way. Okay, his original time is this. His time when he sped up, his pace, his rate is going to be 2 hours less. Again, our time is in hours. Now, again, I know it's a lot, but that's why you have to study math. That's why you have to do a ton of problems. And hopefully, watch videos like mine that fully explain how to solve a problem like this. The next time you run into a similar problem, you'll know these techniques. Okay, so now what is next? You're like, boy, this is a lot of work. What is this taking us? Well, let's go back to the formula. Rate times time is equal to distance. Okay, so rate times time is equal to distance. That means this times this, all right, x times 30 over x is equal to 30. And this rate, x plus 1/2, times this time, 30 over x minus 2, okay, this right here, is also equal to 30. Okay, they're covering the same distance. So this represents this product represents 30 miles, and this product represents 30 miles. So we can actually equate the two. Okay, this is 30 and this is 30. So let's go ahead and construct an equation. And here is our distance. Okay, our rate times time. This is our 30 miles, and then here is our rate times time, which of course expresses 30 miles. So now we have a lovely equation. All right. So at this point, you're like, oh, okay, finally we have an equation. Yes, indeed we do. But what do we do now? Well, we need to solve this equation. And this, of course, is going to bring up a whole nother level of skills, right? So if you want to go ahead and see if you can solve this equation, I would suggest that you do that. But let's go ahead and get into this right now. All right, so again, a lot of algebra skills as promised. So I'm going to go ahead and get into this. If you don't understand anything I'm doing, just make a note of that and work on what you don't understand. Okay, so x times 30 over x, the x is cross canceled. That leaves me with 30. And then here I have a binomial times another binomial. So the way we can kind of do this is using the FOIL technique. All right, so this is going to be x times, this would be first, outer, I'll just write this out, FOIL, first, outer, inner, last. So x times 30 over x is going to be 30. The x's are going to cross cancel. X times minus 2 is minus 2x. 1/2 times 30 over x is 15 over x. And then 1/2 times this minus 2 is negative 1. All right, so are you with me? Good. I hope you are. And, if you're understanding these steps, that's outstanding. Let's go ahead and keep trucking. Okay, so now what are we going to do? Well, we're going to start cleaning this formula up, but you can just see here, we got a 30 here and a 30 here. If I subtract 30 from both sides of the equation, that's just, these 30s kind of go away, right? So this is really going to be equal to 0. That's going to be equal to minus 2x plus 15 over x minus 1. You could combine like terms, 30 minus 1, it's 29, and have 1. Either way, you're going to end up with 1 equals minus 2x plus 15 over x, right? So you can kind of see all that algebra there. So this is where we're at. We have 1 over minus 2x plus 15 over x. So what do we do here? Well, I'm going to suggest that we have an equation with a fraction, okay? We have a denominator down here of x, and this expression, minus 2x, is over 1, and then 1 is over 1. So a good way to clear the fraction in an equation, and matter of fact, it's not only a good way, it's a suggested way, is to multiply the entire equation by the LCD, okay? In this case, it's x. So we multiply the entire equation by x, it will clear the fraction. So let's go and do that now. So this is going to be x times 1. It gives me x. X times minus 2x gives me a minus 2x squared. X times 15 over x, the x's cross cancel. That gives me 15. Okay, so at this point here, we have a lovely quadratic equation. Okay, and now we're going to go ahead and take the next steps. And to solve a quadratic equation, what you want to do is get everything to one side of the equation, typically in this particular case, because we have 3 terms, and set this thing equal to 0. So I'll just move all these terms to this side, so that give me a positive 2x squared plus x minus 15 is equal to 0. Now at this point, we do have some options to solve this quadratic equation. You just don't want to rush in and use the quadratic formula. So what I'm going to do is go ahead and factor this, okay, because this is factorable. This is a big skill right here. If you don't know how to factor, again, a major algebra skill that you need to know. But anyways, this trinomial factors into 2x minus 5 times x plus 3. And of course, that's equal to 0. And the benefit of this is that we can use the zero product property. We can set each of these binomials here equal to 0, right? So this times this is equal to 0, meaning that this or both one of these or both of these must be equal to 0 if we multiply these guys together and we get 0, right? So we're going to set each of these binomials equal to 0 and solve for x. Okay, so when we do this, we get x plus 3 is equal to 0. When we solve for x, we get x is equal to negative 3. Now remember, x was the variable that we represented. That is the speed of the man walking, his original speed. It's in miles per hour. But we have negative 3 miles per hour. This doesn't make sense, right? We're not walking backwards, so we're going to throw this solution out. And then let's take a look at this solution. We have 2x minus 5 is equal to 0. We're going to bring that 5 over to the other side and then solve for x. So we get x is equal to 5/2 or 2.5 miles per hour. So this is the solution. Now there is a step here I'm not showing. Okay, it's kind of a little technicality, but it's actually a pretty big thing. And right here, when I cleared the fractions by multiplying by x. Now this is one approach you could take, but anytime you multiply both sides of the equation by a variable, you can introduce what we call extraneous solutions. You can get extra solutions, and the only way you're going to be able to kind of figure out whether in fact you've got an extraneous solution is by plugging in your solutions into the original equation. That's a whole nother discussion. But in this case, we'll just kind of wrap this up because this has been a long video, long solution. Here is our final answer. X is equal to 2.5 miles per hour. Now, if you have this expression by watching this video, if you're just like, this is why I hate algebra, maybe you got some smoke coming out of your hair and you're just like, your hair's up like this. Listen, I totally get it, okay? But what you need to do is kind of get some Zen going. I don't know if you know what Zen is, but you just need to kind of slow your mind down, kind of do, in some ways, kind of do some meditation, do some deep breathing, and just calm yourself down. Because when you are upset, you're not going to be able to think. Okay, but you need to set the expectation that when you are taking on an algebra word problem, okay, you can run into some pretty challenging problems, okay? And here it's like a journey, right? You start here, you're going to finish here, and you're going up mountains and valleys, and maybe you have to go up this cliff, and you just don't know what that journey is going to be like. So you have to have a good mindset and just follow the paths, right? You don't know exactly how it's going to work out, but you do know that there will be some answer to the problem. You just got to stick with it. And the only way you're going to be able to walk this journey is by having the necessary skills in your backpack, right? The necessary algebra skills, solving equations, factoring, working with formulas, understanding how to model situations, understanding that rate times time is equal to distance, having a awareness of units of measure, etc., etc., etc. So here's the bottom line. Okay, the bottom line is the following: the reason why so many students struggle in algebra is because they want shortcuts. They want to just like, yeah, show me the easy way. Well, unfortunately, I've been teaching math for decades, decades and decades, and there is no easy way. Okay, the easiest way is just to immerse yourself in studying all these respective skills and just practicing these problems. And if you stick with that, you are going to be successful. Okay, so hopefully you enjoyed this video. Yeah, I know it was long, but this was a lot to cover. If you did get something out of this, please consider liking it and subscribing. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.